All right, so today we're going to take a look at section 1.5, which is on transformations. So basically, we're going to sketch parabolas, and we're going to look at different ways we can transform them. Okay, what would you have to do to the equation to, say, shift the parabola up, down, left, or right, or even to stretch the parabola out? Okay, so that's what we'll look at. Okay, so in general, if you have a quadratic function, it's written in this form. Okay, f of x equals ax squared plus bx plus c. And now a, b, and c can be any number you want, except a can't be 0. What would happen if you plug in a 0 for a? Anyone think they know? Yep, Hannah?
It would be 0x squared, which you can't do.
Yeah, so if you had 0 times x squared, this part would just get wiped out, and you'd be left with bx plus c, and that's the equation of a, which is what shape? It's a line. Okay, so if you put in a 0 for a, you lose the parabola. Okay, so that's what this says. A, b, and c can be any real number that you want, except a can't equal 0. All right, so I'm going to graph y equals x squared. And then I'm going to graph the same thing, changing the x to a negative x in parentheses. Before I do that, does anyone have a guess what the difference would be? Think if you have an x and you square it, pick a number, and then make that number negative and square it. What's the difference? Andrew?
The parabola would be going down.
All right, so you think it might like flip it over?
Yeah.
Okay. Any other guesses? Yeah?
Instead of going up and down the parabola, somebody faces the left and the right.
Okay, so like almost rotating it?
Yes.
So it might open left or right? Okay, any other thoughts? What might happen? Nothing. You think it'll look the same?
Yeah, because if you have a negative, it turns positive.
Well, let's try it and see what happens. So I'm going to graph x squared. Okay, this is also called the parent function because it's the simplest parabola you can have. There's no shifting, there's nothing. It's just the basic parabola. And then in parentheses, I'm going to put negative x squared. And then I'm going to hit zoom 6 and see what it looks like. Okay, there's x squared. And coming up right now is negative x in parentheses squared. Did I put it in parentheses? Oops. I put it in parentheses, but I put a little too much in parentheses. So if you do it the way that I did it, somebody that talked about flipping it, you get a flip. What I meant to do was that. Just change the x to negative x. Keep the exponent where it was, which is on the outside. So now you can see that depending on which way you do it, it comes out different, but this is what I had intended. Comes out exactly the same. Okay, there's no difference between putting in x squared and then a negative x in parentheses squared on the outside. It doesn't look different, but something did happen. The reason you can't tell is because of the specific shape that I drew. Does anybody know what did happen there? There was a transformation that took place. No guess on what happened there? Think about something you could do to that graph that would transform it, but the picture, the image wouldn't look any different. What could you do? Mike? Which way? Over which axis?
The y-axis.
Yes. If you did a mirror image over the y-axis, it would look exactly the same. That's what I just did. Now, if I picked a shape that wasn't symmetrical over the y-axis, then you would see a difference. Okay? But this shape is symmetrical because the y-axis is a line of symmetry. Okay, so just to kind of summarize what happens here, I already said it to you, but it actually reflects over the y-axis. It's just the parabola is not really a good shape to show that with because you can't see it. And does anybody remember what the lowest point in a parabola is called? Begins with a V?
Vertex?
The vertex? Now, depending on how you draw the parabola, it can also be the highest point if you flip it. Okay, and a lot of what we do today, we're just going to like practice with the calculator. So I'll do something with an equation. We'll try it. We'll plug it in, and we'll see what it does. Like if you put a, say, +2 at the end of the equation. We'll just graph it and see what happens. Okay, I might ask you beforehand what you think would happen. But we'll go through it. Okay, any questions on what a vertex is? Can the calculator find the coordinates of a vertex of a parabola for you? Yep. Does anybody remember how you do it? We did it yesterday with projectile motion. Casey? Remember how we did it? Yep. Yeah, calculating a max or min. Okay, second calc, and then you can go to max or min, depending on which way your parabola is shaped. All right, so we'll graph some of these and see what happens if you put a number in front. Does anyone have a guess what putting a number in front of x squared is going to do? It's going to do something to the picture of the U shape. Yep.
It's going to change how wide it is.
Yeah, it is. It's going to change the width of it. So let's try it and see what happens. So we've got x squared. Let's put in 1/3 x squared. So from when you type in the 1/3, there's two ways you can think about it. You can think about it horizontally, or you can think about it vertically. We're going to think about it vertically. Okay. So imagine that shape in blue was made out of something flexible, and you pushed down on it, right? It would squish out sideways. If you push down, it would kind of expand out. So that's graph in red. We actually say is a vertical shrink or vertical compression. Any question on why that's a vertical compression? Yeah?
I just have a question. Do you put the 1/3 x in parentheses?
I didn't. Nope. Actually, no, I did because if I don't, it would do 1 divided by 3x squared.
Okay, so put the 1/3 in parentheses.
Yeah. So that if you don't put it in parentheses, it would actually put the x squared in the denominator of a fraction, and that's not at all what we were looking for. Okay, so that's a vertical compression. Okay, the graph got kind of squished down versus typing in 2x squared. What this is going to do is take the graph and stretch it out, so it's going to be skinnier. Okay. Imagine that the origin, like the parabola, is glued down right there, and you took the two sides of the blue one and pulled up, stretched it up. Okay. It would make it skinnier. All right, so what is the effect of changing A? Basically summarized right here. If A is greater than 1, it's going to stretch the graph vertically. If A is between 0 and 1, it's going to compress the graph or shrink the graph. Okay, however you want to say it. Okay, so A greater than 1, vertical stretch. A between 0 and 1, the vertical shrink, or the graph is compressed vertically. Questions on? All right, so let's take a look at something. Oh. Now, so far, I haven't talked about what happens if you make a negative, but you don't put parentheses. Okay, it's like putting the negative on the outside, okay, not on the inside with an X in parentheses. And I already kind of showed you what happened, but what happened when you put in a negative? How about Josh?
It went upside down.
Yeah, it's going to flip it. Okay? And there's a big difference between putting the negative inside parentheses with X or putting it outside, like in front of the X. Okay, if you wanted to put parentheses, think of it like that. It's on the outside. Okay, so I'm not going to graph all of them, but I'll just graph like y equals x squared and negative x squared, so you can see the difference. So negative x squared. Okay, so this time the negative is on the outside, which means it's not part of what's being squared. Okay, only the x is being squared. There's the original, and there's what happens when you put a negative in front. Okay, so all these other ones have two things happening. Okay, you would describe them separate. The negative is doing something, and then the 1/3, we just talked about that on the other page. The negative here is going to do something, and then the 2 is going to do something else. Okay, so you describe the negative and the number that's next to it, if there is one. In the first case, there isn't. But you describe them separate. All right, so the negative causes a reflection over the x-axis. Okay, again, that's when you put the negative outside the parentheses. All right, so the kind of the problem you're going to see on the test is something like this. I'll give you a graph. I'll give you the original, and I'll ask you, how would you change the original into the one that I gave you? Tell me the transformations that are involved. Okay, first of all, just to make sure this is clear, how many transformations are happening to change x squared into negative 5x squared? 2. Yep, 2 transformations. Now, the order that you do them in does make a difference, but later on I'll give you a list once we go through all the transformations and tell you the order. But I'll just tell you what to start with. Start with the 5. What is the 5 going to do? Yep. Yeah. So there's 2 things we want to say. One, it's a vertical stretch, but then you have to tell me by how much. And the way we say it is vertical stretch by a factor of 5. Bless you. Okay, so that's the first one. Vertical stretch by a factor of 5. And now the negative. David, what's the negative going to do?
Flip across the y-axis.
I do like the flipping, reflecting, but it's not across the y.
Across the axis.
It's going to reflect over the x-axis. Okay. So reflect over x-axis. We're not going to do too much reflecting with this particular shape over the y-axis because unless you move it from the origin, it looks the same. Okay, but that's what I'd be looking for. Tell me the transformation, but also tell me, you have to be specific. Like, don't just say reflection. What kind of reflection? Okay? Or don't just say vertical stretch. Tell me how much of a vertical stretch. Okay, any questions on that? Okay, I already briefly mentioned this, the order matters, and later on I'll tell you the order to do it in. Okay. For this problem, it turns out that you could switch the order and it would be okay. But I'll give you an order to go by, so if you just follow that, you don't have to worry about it. All right, so let's look at this one. Does anyone have a guess what the +2 is going to do? So to get y equals x squared plus 2 from y equals x squared, we're going to do something to y equals x squared. Yep?
Is it going to move it on the y-axis?
Yes? Which way do you think?
For the +2, move it towards the
Wait, which axis did you say again?
the y.
The y-axis, which goes in which direction? Up and down. So what do you think the +2 is going to do again?
Move it up.
Up, yeah. So the x squared plus 2 is going to move it up, and I'll just show that real quick. So there's x squared, there's x squared plus 2. And you get the same graph, just shifted up 2 units. Okay. So to get y equals x squared plus 2 from y equals x squared, shift y equals x squared up 2 units. All right, and the other one.
Do you treat this like 2 different problems?
Yeah, these are 2 separate problems. Yep. Now, to get y equals x squared minus 3, you would shift y equals x squared. What do you think you would do this time?
Shift it down.
Yes, you would shift down 3. So shift down 3. And if you want to graph that one, you can take a look at it and see it. Yep, that's 2 separate problems. So this kind of transformation is called a rigid motion because it's not taking what you have and stretching it. It's not distorting it. It just takes exactly what you have and puts it somewhere else. Okay, that's it. So if you have something of the form y equals x squared plus k, if k is greater than 0, you shift up, however many units k is. And if k is less than 0, you shift down, absolute value of k units. Now I put absolute value because you don't want to say shift down -3 units. Down is the word negative, so don't say down negative. That doesn't really make sense. Okay. So you can shift up 2 units, you can shift down 2 units. You can't shift down negative 2 units. Okay, nothing like that. Okay, so that's your vertical shift. Does anyone have any questions on vertical shift? Okay. So let's compare that to something like this. So I still have a plus or a minus, but now it's inside the parentheses. Ian, do you have a guess what that plus or minus is going to do, being inside parentheses?
So move the up or down and move it left or right.
yes, it is going to move left or right. And which way do you think x minus 3 would move? 3 units which way? Can you guess? Left 3? Okay.
Right.
Or right 3? No, it's one of those two. Let's graph it and see what happens. So there's the original. And x minus 3 moved it to the right 3 units. How about the plus 2? That would move it left. Okay, so let's write that down for these two, and then we'll kind of write the rule in general. All right, so to get y equals x minus 3 squared, shift y equals x squared, right 3. Which may not be what you expect. You might think, well, if you have a minus 3, the negative direction goes to the left. But it doesn't work that way. Okay, so horizontal shift, you got to be careful. To get y equals x plus 2 squared, shift y equals x squared, left 2. So the way I think about it is I always think about the number that's after the minus sign. I look at this. Okay. Block the minus sign out. Okay. Block everything else out, just look at the number after it. It's a 3. 3 is positive, so we go to the right. For the other one, I would think of it like this. Think of what's inside the parentheses as minus minus 2. And I do exactly the same thing. Look at what comes after the minus sign. Block everything else out. What comes after the minus sign is a negative 2. That shifts everything left 2. So whatever trick you want to use to remember it, but that's how I do it. Think about the number after the minus sign. And if there's no minus sign, just rewrite it like I just did right there. Okay, so this is, again, another rigid motion. We're not stretching anything. We're just taking something and moving it. And the pattern here is if it's written as x minus h, look at the h. Okay, block out the x and the minus. Just look at what comes after it. If h is greater than 0, it'll shift right. If you focus on the part that I just circled and it's less than 0, it will shift left. So horizontal transformation, just focus on what I circled in red. Where's the vertex of a parabola if you don't shift it at all? Just the basic y equals x squared. Where would the vertex be? How about Brandon? Where would the vertex be? Think about when you sketch, where's like y equals x squared has a low point.
Might be the 0, 0.
Yeah, it's at the origin. It's at 0, 0. So there's only two ways you can affect where that vertex is. You can either shift left or right, and you can shift up or down. So if you shift left, right, up, or down, just look at the values you shifted by, and that's where the vertex would be now. Okay? So if you shifted 2 units right and 2 units up, it would be at 2 and 2. And h would be 2 and k would be 2. Okay, so if you want to find out where the vertex is after you shift it, just look at your two values, h and k. Now, only one of those values affects the line of symmetry. Think about your parabola. Would shifting the parabola up and down or shifting it left and right change the line of symmetry? Left and right. Because if you shift up and down, the line of symmetry is still the same. Okay? So k has nothing to do with the line of symmetry because k is shifting up and down. The only thing that affects the line of symmetry is h. And what kind of line is this if it starts out x equals? You mentioned that yesterday. Yep, Ezekiel?
Vertical line.
It's a vertical line. Yep. So your line of symmetry is always x equals, and look at the number after the minus sign. Okay. Any questions on that? So the next one, I'm going to give you a problem, and I'm going to ask you to tell me where the vertex and line of symmetry are. Okay? And you just have to find the h and the k, and that's it. There's only two numbers you need to use. Okay. So there's the parabola. And the first thing I want to know is the vertex. Yeah,
2, -3.
careful.
The way around.
It has to be written like
Oh, yeah.
this. You have to think of it as x minus something. How would you rewrite x plus 2? Can't have a plus sign inside there.
X minus -2.
Yep. There's your h. Okay? So h is -2. I agree with you that k was -3. There's nothing tricky about the one on the end. You just use it as you see it. But the one on the inside, you gotta think about it like that. Line of symmetry starts out with what letter? Starts out with not h. Nope. X. X equals. And now we fill in the number. So Braden, what value here are we going to fill in? A line of symmetry. Yeah, whatever is in the x spot of the vertex. Because shifting down has nothing to do with line of symmetry. So we're going to fill in x equals
That has to be -2.
-2. Yep. We shifted this graph 2 units to the left, so the line of symmetry also moved 2 units left. Okay, so that's what I'm looking for. Questions?
So let's say that was x plus 4 and still -3, it'd still be the same thing, just minus like plus 4 as well. It's like,
Like that?
yeah.
So your vertex, yeah, what did you think it would be?
It could just be the same thing as 4 -3 as well. Different numbers.
Not 4, -3 though. -4, -3. Yeah. Because remember, it has to be written as x minus something. And you look at what comes after the minus sign. So whatever is in that box right there, that's what goes right there. Yep. Okay, any other questions on that? Okay. All right, let's go through the transformations here. Okay. Order does matter, but in a minute, I'm going to give you the order to follow. Okay, so I'll guide you through the order one more time, and then you'll have to figure it out for yourself. Caitlin, how many transformations do you think are happening in this problem? 2. Yep, there are 2. And we're going to start with the 5. So Hannah, what's the 5 going to do?
It's gonna stretch the it's gonna stretch the parabola
Which way?
out.
So your choices are vertical or
Vertical.
just pick vertical? Yeah, vertical. So vertical stretch by how much?
5.
Yes, vertical stretch by a factor of 5. All right. And the second transformation that has to do with the 4. Colleen, what's the 4 going to do?
Sorry, say that again.
What's the 4 going to do?
Part of the vertex.
It would have an effect on the vertex. You don't have to tell me that in this problem. You just have to tell me which way the +4 would move it.
Up.
Yeah, up how many units?
4.
Yep. And yes, but it would have an effect on the vertex. There's no shift left and right here. So the vertex, the x value of the vertex is still 0. But the y value of the vertex would be 4, if they asked for it. All right, let's try this one. Because this one kind of touches on the order, and I'm going to show you the order at the same time we do the problem. All right, so first thing you want to do, and again, these are all if necessary. You might not have every one of these in every problem. But is there any horizontal shifting in example 7? Yeah. Which way are we shifting?
To the right one.
We're shifting to the right one. So shift right 1. Second step. If you have any vertical stretches or shrinks, now you name those. Mike, do we have any vertical stretches or shrinks
What?
in that problem? You're not sure? You want to help Mike out with the vertical stretch? Yeah?
Yes.
Yeah, what number are you looking at?
-3.
Careful. You jumped ahead a little bit.
Just the 3.
Just the 3. That negative is going to be another transformation. I'm going to write that down in the next step. So the 3, that's a vertical stretch by a factor of 3. Now we're going to look at that negative, and that has to do with a reflection. Okay? That's a reflection in the x-axis. And again, you really don't have to put if necessary, because they're all if necessary, really. So reflect over x-axis. And the last thing is if you have a vertical shift. Do we have a vertical shift here? Well, Curtis?
No.
Well, we didn't do anything with the +4 yet.
Oh, yeah.
So, yeah. What's that +4 going to do?
Is it off the, like where the vertex is?
Yeah, just tell me how the picture is going to move of the parabola.
And go
Up 4. Yeah. Shift up 4. So that's the order that we'll always follow. We didn't really mention horizontal stretches. If you were going to throw that in here too, that would be like putting a number in front of x like that. Okay, I'm not going to do that on these problems because I just want to stick with what we have. And a horizontal stretch would be dealt with right there. It would be between steps 1 and 2. So you kind of start on the inside of the parentheses and work your way out. Deal with the 1. Then you deal with a number in front of the x. Then the thing that's right on the outside of parentheses. And then the plus 4. All right, so all the equations we've done so far have been written in standard form. What we call standard form. Let me take the equation we just did in example 7, I think, and rewrite it in a different way by doing it out. I'm going to FOIL out x minus 1 squared. So I'm going to do this. So I get x squared minus x, and negative 1 times negative 1 is plus 1. Now I'm going to distribute out a negative 3. Get negative 3x squared plus 6x minus 3. And now I'm finally going to add the 4 just to combine like terms. If you graph what I just circled, and you graph the original problem, they're exactly the same thing. Okay? There's no difference between these two. But this version of it, it's a lot harder to figure out the transformations. Because we've shifted up 4. There's not even a 4 in this problem anymore. I can't even tell that. So this is not a good way to have a problem written. So if you're given a problem that is, let me show you an example. If you're given a problem that's written in the way that I just had, like ax squared plus bx plus c, where somebody did out all the foiling, that's not helpful. We want to get it back looking like that. So in the last problem, I think it's the last problem. Yeah. I'm going to show you how you can take and get that to look back the way it was before you distribute everything out. And the way you do it is to complete the square. Now, completing the square is something you do probably back in Algebra 1. I'm going to go through it as an example, but I'm not going to write out every single step of how to complete the square. I'm just going to show you in an example. Okay, but I'll say it. Okay, does anybody remember that term, seeing the term completing the square before? Remember it? Okay. Usually the people remember it, but not exactly remember how to do it. Does anyone remember how to do it? Yeah. But I'll tell you the steps, and then we'll do it on this problem. So the first step is to put the constant on the other side. Step 1. Put the constant on the other side. The constant is the thing without a variable. So how would I move 18 to the other side? Add it. Step 1. Step 2. You have to make sure the number in front of x squared is a 1. To complete the square, the number in front of x squared has to be a 1. So the 18's fine.
Wait, did you just get rid of the y?
Yeah, I just basically pretend like it was this. Pretend like you're solving a quadratic, like it's equal to 0. And we just add 18 to put that on the other side. We'll put the y back in at the very end. Okay? What could I factor out of x squared to get rid of that 3? Yeah, factor out a 3. And Josh, what would that leave me with inside parentheses?
X
x squared plus 4. Good. So step 1, put the constant on the other side. Step 2, make the number in front of x squared a 1, which it is now. And then the last thing we have to do is now complete the square. Yeah?
Did you 12 have an x next to it, or did you get rid of that too?
Oh, yes, thank you. That stays right there. Thank you. That's important. Okay, now we're ready to complete the square. Out of the numbers that I have up here, the 18, the 3, and the 4, does anybody know which one of those numbers you use to complete the square? The 3? Nope, not the 3. Any other guesses?
4?
Yeah, we're going to use the 4. So you have to do 2 things with the 4. First thing you have to do is take this number and take half of it. When you take half of it, what does that give you? 2. The second thing you have to do is square it. So when you square what you just said, what do you get? 4. So in this case, not very interesting, but that's what you do. Take half of the number in front of x and square it. That's that step. Now, what did I just add to the right? Because I said keep everything balanced. Careful. I didn't add 4. What did I really add? I added 12. How come? Yes. Anything you put here is really 3 times its value, okay? Because it's a distributive property. So you added 12 on the right. You need to add 12 on the left. You have to do the same thing on both sides. That's the part that usually trips people up. That part doesn't always happen. Okay, it depends on the problem. All right, so now we've got 30 equals 3. And this should factor very nicely. It has to factor into 2 things that are the same, like x plus 1, x plus 1, y minus 7, y minus 7. Does anybody see how this factors here? X plus 2, x plus 2, which is just x plus 2 squared. And now I said at the very end, we're going to put the y back. And we're going to do that by putting everything back on the same side. So y equals, and subtract the 30. Okay, so after we complete the square, now we've got an equation where we could write out the transformations. Shift left 2, vertical stretch by a factor of 3, shift down 30. You can't really tell that from the original problem. Okay, so you wouldn't have a lot of problems like this because these are kind of time consuming, but you could have one. Okay. Any questions on that? Not a hard method, but you just might have to practice it a couple times before you remember all the little steps. Okay. And as I said, that was our last example for today. Okay. But the last thing I'm going to mention is how you can look at an equation and tell how many times it crosses the x-axis without solving it. Solving it will certainly tell you the answers, but if you just want to know how many times it crosses the x-axis, there's a quick way to do that. So first of all, quadratics can cross the x-axis 0 times. They can cross once, which is more of just like touching it and going back up. Or they can cross twice. Everywhere that a parabola touches or crosses the x-axis, that's called a 0. That's a 0 of the function. And quadratics can have 0, 1, or 2 zeros. And the quick way to figure out which case it is to evaluate that expression. Has anybody seen that before? B squared minus 4ac? Yeah, what's that from? It's from the quadratic formula. Specifically, it's the thing that's under the square root. So if the thing under the square root, which it's actually not called the thing under the square root, it's called the discriminant. If the discriminant comes out less than 0, you would get this situation right here. It would never cross the x-axis. There would be no zeros. If the discriminant comes out to exactly 0, it would be that situation. It would just touch the x-axis once. If the discriminant comes out positive or greater than 0, it would be that situation. Now this trick doesn't give you the answers faster. It just tells you how many answers there are, not what they are. Okay?
So like, can you say that again, which one is which? Because you like circled them when I was right.
So if I could use different color, actually I'll just go like this. So this situation is that one. This situation is that one. And this situation is that one. Either crosses twice, once, or not at all. Any questions on that? All right. So homework tonight, it's on page 56. And just kind of jumps around a little bit. So 1, 2, 7, 10, 11, 16, 18, 21, 22, 28, 33, and 40, 41, 44, and 16. Okay, we'll go over that first thing tomorrow, and then tomorrow we'll finish up chapter 1.